Hello students, very good evening to every one of you and welcome to my channel Academy Master. Okay, so today we are going to discuss the next topic, that is hyperconjugations. We are going to discuss class 11 chemistry chapter number 12. Okay, so what is hyperconjugations? Let us start with. So hyperconjugation, it is the interactions between the electrons of the pi system. Okay, it is that means what? It is the interactions between the electron of the pi system means what? This hyperconjugation, basically it will take place in those compound in which there is a multiple bond. Okay, that's why we have written here pi system. And the adjacent sigma bond means the bonds, the sigma bond which will be adjacent to the next to the pi bonds between them, the bonds between the bond which is adjacent to sigma bond and the bond which is adjacent to pi bond and the sigma bonds, in between this the interactions will be there. So all the substituted group in an organic compound, we call it as what? Hyperconjugation. For example, you can see here, this is what, a sigma bond or not, and this is pi bond. So next to this pi bond, this is the sigma bond. So the interactions between these two bonds, sigma and pi bonds, we call it as what? Hyperconjugation. So what happens in hyperconjugation? In hyperconjugation, you will see this double bond is there. The double bond will be broken and the electrons will be shifted to the next carbon. So the double bond is broken and the electron is shifted here to this carbon. When this double bond will be broken, the electrons will be shifted here, and the adjacent sigma bond, that is the bond with the hydrogens, it will be broken, and the bonds, these electrons will be shifted here and the double bond will be formed, as you can see. And it is not necessary that this this bond only will be broken. In the next step you can break this bond also. In the next step you can break these bonds also. So here it is written HCH and here it is H positive. Why? Because this hydrogen has lost the electrons, and that electrons which has been removed from here by the cleavage of the bond, that will come and it will lead to the formation of a double bond here. So you can see the double bond is formed here, and this double bond which it was having pi bond, it is broken and the electron is shifted to the next carbon, that is here. You can see two lone pair of electron, clearly you can see. Okay, so again in the next step, if you go, this bond will be broken again, same steps. Okay, so this process is called as what? Their interactions between the electron of the pi system and the adjacent sigma bonds okay, is called as nothing but hyperconjugations. The order of hyperconjugations, okay, the order of reactivity of hyperconjugations. So order of hyperconjugation decreases. So always remember, the one which will be less methylated, they will be highly they have the more reactivity. Okay, so you see here only one methyl group, so the reactivity is very high. Here the methyl group is 2, here the alkyl group is 2, so the reactivity will be little high, and here you can see the alkyl group is 3, so the reactivity is again less, and at last you see CH3 CH, so here the reactivity will be very less. These orders and all, dear students, it is very important for your competitive examinations, so you have to keep it in mind. Now what are the applications of hyperconjugation? The applications of hyperconjugations are: number 1, it helps in shortening of a carbon-carbon single bond adjacent to the multiple bond. Okay, so by the cleavage of this bond, this bond will be gone, so it helps in shortening of a carbon-carbon single bond, means it helps in reducing the carbon-carbon single bond which are adjacent to the pi bond. This is a pi bond adjacent, how many carbon-carbon single bond will be there? That one will be shortened up. Okay, that is one of the application of the hyperconjugation. Another application is what? Relative stability of the methylated alkene. It helps in understanding the relative you can say relative stability of the methylated alkene. Methylated alkene means those which are containing alkyl groups. Okay or not? So these are the applications. This is the applications, and this is the definitions of a hyperconjugations. So this one is very important, all of you should take down, and then we can proceed to the next topic. Okay, dear students, now we are going to do types of bond fission. Bond fission means a type of breaking of a bonds. Okay, so there are two types of bond fissions. Okay, and these are very important for your board examination. Again, I am telling you, and plus for your knowledge also, it is very important in the chemistry. All these things knowledge you should have. Okay, so there are two types of bond fission. Number one, homolytic bond fissions. Okay, so what is homolytic bond fissions? So basically you have to understand one thing. Homolytic bond fission basically occur in homogeneous compounds, like example H2. So this is homogeneous compound HH. Okay, C2, CC. Like in this kind of compounds you will see that homolytic bond fissions it will be occurring. Okay, in which sense some kind of the bond is formed between same kind of atom, hydrogen, carbon, oxygen. These are in these cases of bond fissions in these compounds, like where you will have same kind of compounds atoms. In that bond fissions will occur. That bond fissions we call it as homolytic bond fissions. Okay, again I am telling you, homolytic bond fissions generally occurs in homogeneous compounds like H2, C2, B2, Br2, all these things. Okay, so let's see what is actually homolytic bond fission. So the cleavage of the covalent bond. Cleavage means what? Breaking of a covalent bond between two atoms. Between two atoms will be there. So the cleavage of a that means the breaking of a bond between two atoms. That means one atom is hydrogen, another atom is hydrogen. This is one atom of hydrogen, another atom of hydrogen. The cleavage of the covalent bond, the bond between them is covalent bond between two atoms. So these are the two atoms in such a way that each bonded atoms, retain one electrons of the shared pair. So always remember, this is homogeneous, means the electronegativity, this hydrogen and this hydrogen, they will have the same capability, the same power to attract the electrons, pull the electrons towards themselves. So whenever the bond is broken in between them, what will happen? A bond consists of two electrons. Okay, always remember that a bond is made up of two electrons. So when the bond will be broken, always remember, dear student, one electron will be shifted to this hydrogen and one electron will be shifted to this hydrogens. Why? Because both of them, they have the equal capability or equal electronegativity to attract the electrons. Okay, you can just imagine that two persons are there, who are equally powerful. So whenever you are sharing something, you will share equally. You have no options to go for a partiality or go for injustice, right? So same thing is here, both hydrogens only, so both are having same power. So what will happen? When the bond will be broken, two electrons will be released, and one electron will go to one hydrogen atom, another electron will go to another hydrogen atom. Bonded atom retain one electrons of the shared pair. So just imagine that A and B, this is two atoms, and they have formed a single bond between them, that is covalent bond. So this bond, it is made up of two electrons. As you can see, there is two dots, so it is made up of two electrons. So when this bond will be broken, since they are both having equal power, that is equal electronegativity. What is electronegativity and all we will be studying in chapter number 4. Okay, so the electrons, when the bond will be broken, the bond will be cleavage. Cleavage means breaking of a bond. So when the bond will be broken, always remember, one electron will be transferred to this A and another electron will be transferred to B. Why? Because both are equal in strength. Both the electronegativity is same. So after gaining one electron, this A, and after gaining one electron, this B, will be called as what? Free radicals. Now what is free radicals? In the later part of the chapter we are going to explain to you. Okay, so this kind of bond fusions, in which after breaking of a bond, each atoms get equal number of electrons, it is called as what? Homolytic bond fusions. Next is what? Heterolytic bond fusions. So heterolytic bond fusion is what? Heterolytic bond fusion generally occurs in the heterogeneous compound. Heterogeneous compound means, I will say that CH. Okay, 4. So you can see that CH, so C and H. So these two are different atoms. So this is called as what? Heterogeneous compound. A compound which is made up of different atoms, so they will be called as heterogeneous compounds. Okay, now here when the cleavage of bond will occurs, when the cleavage of bond will take place, suppose the bond between carbon and hydrogen is broken, this is a covalent bond, it is broken. Always remember, dear students, as hydrogen is weak, their electronegativity is less. So when the bond is broken, carbon is very strong or very powerful. So what carbon will say to hydrogen? Okay, you don't need to take electron, give me both the electrons. So hydrogen, being a weak person, so okay boss, no problem, you take both the electrons. Okay, so in heterogeneous you will see that after the cleavage of bond, both the electrons will be going to carbon and hydrogens will get nothing. But since actually the electrons, these two electrons are there, that electron, one electron is contributed by hydrogen, one electron is contributed by whom? Carbon. So as per the rule they should get equal electrons, but since carbon is more electronegative, that is more powerful, what will happen when the bond will be broken? Carbon will take away both the electrons. As a result, carbon will get negative charge, and hydrogen, it is giving away, not willingly but forcefully, it is giving away its electrons. So hydrogens will get here what? Positive charge, bichara. Okay, got it or not? Hydrogen will get a positive charge. So that is called as what? Heterogeneous heterolytic fissions. So now let us see what is the definition of heterolytic fissions. The bond the bond breaks in such a way that one fragment takes both the electron, means one atom will be taking both the electrons of the shared pair, leaving none for the others, means the other one will not get anything, like here hydrogen do not get anything. So see here A and B, they have formed a bond. Now when the heat is, when we are heating it, the bond is broken. Now always remember, one bond is broken, two electrons is released. So when these two electrons will be released, now since B is more powerful than A, that means powerful in a sense they are more electronegative, means their capability to attract the electrons are very high. So the B will take away both the electrons, leaving nothing for whom? For A. As a result, A will get positive charge, and since B have gained the electron, so they will get a negative charge. Always remember, the one who is losing the electron, they get always positive charge, and the one who is gaining the electron, they get always negative charge. So why B is getting the both the electron? Because B is more electronegative, that means their strength to attract the electron is more comparing to A. Understood? Okay, so in this case B will be called as what? Carboanion, and A will be called as what? Carbocation. This one will be called as cation and this one will be called as anion. So now what is carboanion we are going to discuss, and in the few minutes later on we will be discussing what is carboanion, also what is free radicals, all these things we are going to discuss. Okay, so carbocation, what is carbocation? Atoms or group of atoms which contains an atom, or it is not that only one atom will be there, it can be a group of atoms also. An atom or group of atoms which contain positively charged carbon atoms having only 6 electrons in their its valence shell are called as carbocation. For example, you see here in the bottom there is a bond between carbon and X. X here represent, dear student, always remember, bottom it is example is like this, it is not visible, so I will tell you. X, here X represent halogens. Halogen means what, dear students? Halogen means chlorine, fluorine, bromine and iodine. Okay, out of this anything can be here. Okay, and always remember that group 17, these are all group 17 element and they are highly electronegative. Okay, so that means their capability to attract the electron is very high. So when the bond between the carbon and these halogens is broken, since these X, that is halogens, are very much powerful, they are very much highly electronegative, so the halogens will take away both the electron, leaving nothing for the carbon. As a result, what will happen after the reaction? You will see carbon will be gaining what? Positive charge, and halogens will get a negative charge with 2 lone pair of electrons. So this carbon will be called as what? Carbocation. Okay, so this is also very important definition, generally comes in your exam for 1 to 2 marks. So you have to remember it. This thing you need to know it properly, dear student, in class 11 itself, or else when you go to class 12 it will be very difficult for you if you don't know these basic things. Okay, dear students, so what is carbocation? I hope you have understood. Got it? Pause the video and you can take down the notes. Okay, students, so we are back. Now, free radicals. What is the free radical? As I have discussed a few minutes ago, now we are going to define what is free radical. So free radicals, it is defined as an atom or group of atom having unpaired electrons. Okay, single unpaired electrons. So see here, not double unpaired electron, okay, a single. So it is defined as an atom or group of atoms having an unpaired electrons, and it occurs only in homogeneous compound. Again, I am telling you, it will occur only in a homogeneous compound. Okay, it will never occur in heterogeneous. Homogeneous means same kind of compound, like Cl2. So if you draw the bond for Cl2, Cl, Cl. So when the bond will be broken, it will be Cl like a 1 electron, and here also Cl1 electron. So they are called as what? Free radicals. Okay. So see here, A and A. This is same type of atoms, so homogeneous atoms. So when the bond will be broken between them, okay, when the bond will be broken between them, as I told you, both are having same electronegativity. So each atoms will get one electron. So here electron A1, first atom has got 1 electron, second atom has got 1 electron. So this species, this one and this one, it is called as what? Free radicals, and they are very reactive. They are very reactive. Okay, they are very reactive. They are just like the boys, like we boys, right? When we are singles, we are desperately in search of some partners, some girlfriends and all. That time we are very much reactive. But once the persons get married, then his reactiveness, of course it will be there, but it is not that much, right or no? Same is the case here. Okay, so when they are singles, they are very much reactive. They are always reactive. They are in search of some other atoms to get paired up. Okay or not? So always remember, free radicals are very, very reactive. Okay, now carboanion. Carbocation already I have discussed few minutes before. So what is carboanion? A species containing a carbon atom carrying a negative charge. Carbocation was what? Carrying a positive charge. Here it is carrying a negative charge and possessing 8 electrons in its valence shells. Okay, so that is called as what? Carboanion. Now you see here you can see CH3, and this is bonded with Z. Z can be any atoms which is less electronegative than carbon. Z is atoms which is less electronegative, okay, which is less electronegative than carbon. So when the bond will be broken, what will happen? The electrons will be shifted towards the carbon. So the carbon will get the 2 electrons, because one bond is broken means 2 electrons is there. The 2 electrons will be shifted to whom? Towards the carbon. Okay, so carbon, since it is gaining the electron, always remember, dear student, if there is a gain of electron, there will be a negative charge, and if there is a loss of electron, there will be a positive charge. The one which is losing the electron, they will get positive charge, and the one which is gaining the electron, they will get a negative charge. So carbon has gained the electrons, so that electrons which it has gained, we have represented here. See, double dot is there, that is an electrons, and since it has gained, so negative charge, and now the carbon will be called as what? Carboanion. Carbon with negative charge, we call it as carboanion. Carbon, when it has positive charge, we call it as carbocation, and this is Z positive. Okay, so hope you have understood what is carboanion. Now we are going to discuss type of attacking reagents. So these are called as what? Reagents. Okay, these are called as reagent, or we call it as attacking reagent. So how many types of attacking reagents are there? The first attacking reagent is free radicals, so we have already discussed. Now another one is what? Electrophiles. So dear students, again I am telling to all of you that try to understand the basic concept. I am not teaching you very depth, I am just teaching you the basic thing. If you learn this basic thing properly, then next year class 12 organic chemistry, it will be very much fun for you and you will enjoy learning it. Okay, so electrophiles. What is electrophiles? A attacking reagent that takes away an electrons. What is an electrophile? Electrophile is a reagent that takes away the electrons. They will take away the electrons. Okay, pair is called as an electrophile. The attacking reagent which takes away the electrons from the carbons or any compounds are called as what? Electrophiles. So electrophiles features, this is the definitions, and these are some features. The electrophiles for whom? Those electrophiles are hungry, they are poor persons, they don't have the electron. Poor person means don't bring in other way, they are poor in a in sense of electron. They are in need of electron, they are desperately in need of electrons, so they have a electron deficiency. So they are electron deficient species. Okay, they are in short of electrons. Okay, and they are also called as what? Electron lover. These electrophiles, they are also called as what? Electron lover, because they want electrons. So some example of electrophiles are H positive, H3O positive, Cl positive. These are all electron lover. They are desperately in need of electrons. Okay or not? So they are called as electrophiles. Now electrophiles are also, there are two types. We will be discussing it now. Okay, got it? First you pause the video and you can take it down the notes. So dear students, a few minutes before we have discussed electrophiles. So electrophiles are what? Electron lovers. They are electron deficient, they want electrons. So I told you that there are two types of electrophiles. So here are the two types. One is positively charged electrophiles. So Cl positive, Br positive, CH3 positive, etc. There are many more positively charged electrophiles are there. Positive means they are electron deficient, they don't have the electron, they have lost their electrons, so they are definitely desperately in need of electrons, so they are positively charged electrophiles. The second type of electrophiles are neutral electrophiles. So neutral electrophile is AlCl3, BF3, SO3. So these are neutral, as you can see any charges over this, so they are neutral electrophiles. Okay, now nucleophiles. Okay, the second type of attacking reagent is what? Nucleophiles. So nucleophiles are what? A reagent that brings an electron pair is called as nucleophiles. Means those nucleophiles are what? Electron rich. They donate the electrons to others. Okay, they have lots of electrons, they have excess of electrons with them, so they are willing to donate. They are very generous persons. Okay, nucleophiles. So nucleophiles, they are what? Electron donors. Okay. So they are electron rich species and they donate the electrons to others. Okay, example NH3 positive, here 2 electron, you can say this 2 electron is excess, so they want to give to other if somebody is in need. Cl negative, they are also having excess of electrons, they want to donate. Br negative, they are also having excess of electrons, so they want to donate. Okay or not? So nucleophiles are what? Electron donors, and electrophiles are what? Electron gainer. Accepted. Okay, types of nucleophiles, same way, they have negatively charged nucleophiles and the neutral. Negatively charged nucleophiles are OH negative, Cn negative, OR negative, RCOO negative, NH2 negative, etc. Many more are there. So these are some basic, you should know the example as well as the types as well as the definition. Dear student, one question comes for one definition along with the types, it comes for 2 marks. So very important, it becomes very important for your board examination as well as for the basic knowledge of chemistry. Okay. Neutral. Neutral are what? As you can not see any charge here, water is also a neutral nucleophiles, and NH3 ammonia, it is also a neutral nucleophiles. R3, and this is also a neutral nucleophiles. So I hope electrophiles and nucleophiles concepts are clear. Now we will do next the difference between electrophile and nucleophiles, and then we will proceed to the last topic of these chapters. Okay, till then you can pause the video and take down the notes. So now we are going to study the differences between the electrophiles and the nucleophiles. Okay. So electrophiles and nucleophiles. So first difference is what electrophiles are: electron deficient species. We have already studied. Electrophiles are nucleophiles are what? Electron rich species. Number two, they behave as Lewis acid. What is Lewis acid and all we are going to study in the chapters, other chapters, equivalent chapters. So this we understand that they behave as a Lewis acid and they behave as a Lewis basis. Okay, means electrophiles behave as a Lewis acid and nucleophiles they behave as a Lewis basis. They are either positively charged or they are neutral species, whereas in nucleophiles they are either negatively charged or neutral species. Okay, dear students, this is the difference between electrophiles and nucleophiles, and in the exam you have 2 to 3 mark questions asked in your board examination, so that's why you need to remember this. Okay, both in the state board and CBSE. So dear student, you need to remember this. Now we are going to study about different types of reactions. Okay, substitutions, eliminations, and all those reactions we will be studying. But now you can pause the video and you can take down the notes first. Okay students, now we are back with the type of organic reactions. The first type of organic reactions we are going to discuss is substitutions reactions. What is substitutions reactions? Let's go for the definition, then we'll try to understand. Okay, so the reactions in which an atom or group of atoms in a molecule is replaced or substituted. An atom in which or a group of atoms in a molecule is replaced or substituted by different atom or group of atoms are called as a substitutions reaction. By the name substitution itself, it is clear. Like in place of one, we will be replacing it by others. Like in the footballs and all, we have a substitute, right? Once one get injured, we are replacing that person with somebody else. Like one person is injured, we cannot replace two persons. One person injured means we have to replace it by one only, right? Same thing is valid here also. When you are replacing one atom will be replaced by another atom only. Two atoms you are replacing, two atoms is we are taking out from there, then two atoms we will put from here. Okay, so for example, let us try to understand in a better way. CH3Br. Okay, so another one is NaOH. So here what we are doing, here Br is, how many atoms of Br is there? Only one. And here how many atoms of OH is there? Only one. So OH will be replacing Br and Br will be replacing OH. So Br will be coming in the place of OH and OH will be going in the place of Br. So after the reaction you will see CH3OH. See, Br is replaced by OH or not? And OH is replaced by Br. So these reactions we call it as what? Substitutions reactions. We have substituted in place of Br OH and in place of OH Br we have substituted. So these reactions we call it as what? Substitutions reaction. Very simple it is. Now next one we are going to discuss addition. The second type of organic reaction is additions reactions. So organic reaction in which two molecules reacts to form. Addition reaction is with what? When two molecules react to form a single product. When in which two molecules reacts to form a single product. Two molecules will be reacting and they will combine together and they will give us a single product. Having all the atoms of the combining units are called as addition reaction. Means they are not going to remove anything. Whatever it was there between the two, it will be there. But only difference is earlier they were two separate and now they will be together. So see, CH2 double bond CH2 plus Br2. So when they will be added, they will give us one product CH2. This Br, one Br, two Br is there. One Br will go and combine here. Another Br will come and combine here. So it will be giving us what? CH2Br, single bond CH2Br. Okay, so they give us what? One single product or not. So this is called as what? Additions reactions. And the last type of reactions we are going to discuss now is eliminations reactions. And with that we will be finishing up these chapters. So all of you can pause the video and take down the notes. Okay, students, we are back now with the third type and the last type. Many are there type organic reaction, but this much portion is included in your syllabus. So eliminations reactions. What is elimination? By the name itself, elimination means to remove. We have to eliminate something. So the reaction in which two atoms or group of the molecules are removed are called as eliminations reaction. I'm giving you the simplest exam definitions. Okay, don't want to give you hi-fi language and confuse you. Okay, so simplest definitions I'm giving you. Try to memorize it properly and try to understand it. So here it is CH3 it is, CH2Br it is. Okay, in the presence of alcoholic KOH, potassium hydroxide, when we treat it with potassium hydroxide, then you will see that this Br and this H will be eliminated, means removed. Okay, group of atoms. This is a group of atoms, so it will be removed. So what is left here now? CH2, and here it can't be single bond, so we will put it in double bond plus HBr. Okay, so here HBr is what? Removed. So this is called as what? Eliminations reactions. Now eliminations reactions also, there are three types. In your exams they used to ask what is elimination reactions, give its types with examples. So it comes for 3 marks. So dear students, try to learn it properly. Definitions I have not given, but I think with the example I will explain you can write by your own. Types of eliminations reactions. So the first type of elimination reaction is alpha elimination reaction. Alpha elimination reaction means what? Here the halogens as well as the hydrogens. Okay, halogen means chlorine, fluorine, bromine, iodine. So halogen as well as hydrogen both will be removed from which position? From the alpha position. Alpha position is what? Let me first try to explain you. Alpha is that position, the carbon to which halogens are attached, functional groups are attached. Okay, they are called as alpha carbon. So see this carbon, with this carbon halogen is attached or not. So this one will be called as what? Alpha position. Now alpha elimination means what? Hydrogen, one hydrogen and one halogen, both will be removed from the alpha position. So this hydrogen and this chlorine, it will be removed at the end of the reactions. So that is why this elimination reaction we call it as alpha elimination. Alpha elimination means one halogen and one hydrogen, both will be removed from which position? From the alpha position. You see minus H. So right now this bond is broken, a hydrogen is removed. So carbon has got the 2 electron, negative chlorine. In the next step again we have removed what? Chlorine. From which position? From the alpha position. So last what we are getting? CH3, CH3 double 2 lone pair of electron. This is called as carboanion. Okay, so this is an example of what? Alpha eliminations reactions. Alpha elimination reaction means both the halogens as well as hydrogen, it will be removed from which position? From the alpha position. The second type is what? Beta elimination reaction. Beta elimination reaction means, remember dear students, here beta elimination reaction means the hydrogen will be removed from the beta position and halogen will be removed from the alpha position. I repeat, beta elimination reaction means hydrogens will be removed from the beta position and halogens will be removed from the alpha position. So this is alpha carbon. This is alpha carbon because here Br is attached, so it will be called as alpha carbon. The carbon next to it is called as beta carbon. So you see, from the beta position hydrogen and from the alpha position we are removing halogens. That is Br. So you will get CH3, CH2, CH2, and here one Br and one hydrogen is removed. So here it will be double bond CH2 HBr in the presence of alcoholic KOH. Okay, so this is an example of what? Beta eliminations reactions. Remember, beta elimination means from beta position hydrogen and from alpha positions halogens. The next one is gamma eliminations reactions. So gamma is what? Alpha, beta, gamma. Next one will be gamma. So we have taken simple examples. So see here Br is there. So this one we are considering it as alpha positions. Left hand side. You can consider this one also, no problem. This is alpha, beta, and this one is gamma. So from alpha position also halogens is going to be lost. From beta position also halogen is going to be lost. So these reactions we call it as what? Beta eliminations reactions. Okay dear students, gamma eliminations reactions. In gamma there is no loss of halogens, no loss of hydrogen, there is only loss of halogens. 2 also halogens will be lost. From which position? From alpha as well as from the gamma position, halogens will be lost in the presence of, we need a catalyst to remove it. So in the presence of zinc dust, so we will get the compound this one. Okay, dear students, so thankful to all of you for your cooperations that you have given to me, with the help of which I have completed the first chapters. That means we have completed class 11 syllabus. For how many marks we have completed? We have completed for 8 marks. So this chapter consists of 8 marks, and it was a very important chapter for your chemistry, organic chemistry basic development. So we have done today. We have come to the end of this chapters. Whatever things I have given you, if you make a proper note and try to study it properly, then your basics will be clear. Got it or not? But first of all, you need to study these things properly. Okay, don't go here and there, this channel, that channel and all. Of course you will get lots of knowledge in different channels. Good teachers are also there. I'm not telling they're bad, they are very good, even much better than me. But first of all, if you learn this basic thing, because these are basic and I've taught you in the simplest way, because right now you came from class 10, so your knowledge regarding chemistry may not be that good. So that's why I have done it in a simplest way, so that you can understand the subject matter properly. Okay, so I request all of you to go for studies. Okay, and after completing these chapters, I think I will be going for a test on this chapter. So dear students, try to complete the chapters. I have completed it. You try to study it properly. In the next class we shall have a test, and don't forget to share the video with your friend, at least 5 friends who are studying in other schools or other states, so that they can also get a help from these videos. It will be benefit for them also. Okay, and of course, if you have any doubts in these chapters, don't hesitate to comment whatever doubt you have. Okay, so with this we complete chapter number 12, basic organic chemistry, for general organic chemistry for class 11. Okay, so congratulations all of you, and if you are new to the channel, please don't forget to subscribe it, and when you subscribe, it gives us an encouragement to do better. Okay, and don't hesitate to share the videos with your friends, so that they can also get a benefit with this. With that, we will wind up. Thank you.